All right, so for this set of videos, we're going to really focus in on manipulating limits and having a solid understanding of how a slope is formed. So hopefully right now you're seeing this fun little GIF of how we evaluate slopes. So normally slopes are evaluated by doing, let me go ahead and find my marker. Slopes are evaluated by doing y1 minus y2 all over x1 minus x2. Heck, you could see it in reverse direction. You could see y2 minus y1 or x2 minus x1. We're going to rewrite this as f of b minus f of a over b minus a, because we are going to say these are 2 points, x equals a, x equals b, and the y values, y1 and y2, are f of b and f of a. So it's just rewritten in a slightly different way. Now, what you see being animated is a different version of that. So we are going to actually have this rewritten and say that this c is actually a b value right here. And then the thing that's moving, so that dotted line that's moving back and forth, okay, that is going to be a, but in this situation, a is not a set value. Rather, what's happening here is we're doing b plus some distance h. So we are speaking in very general terms here. We're speaking in terms of, yeah, we're starting with a point, and then we're ending at some point h spaces away from it. So it's kind of a different way to think about it. And if you notice, it's using delta y and delta x as the symbols there. Delta means change. So it's still the same principle of change in y over change in x. Now, here's why we have this animation happening. We are using this as a general foundation to construct a slope at one single point, rather than forcing ourselves into 2 points, requiring ourselves to use y1 and y2, x1 and x2. We are now going to find the slope at just one single instance. So this orange dotted line only touches the blue curve one time. It is a tangent line. So because it only touches the blue curve one time, we need to know what is the exact slope at this one point right there, at f of c, or in this case, b. So here's where the calculus comes into play. You gotta follow along with me because this is some good old limit manipulation. When we're looking at this, we are going to say, okay, if this distance between the 2 points is h, to be at one single point instead of at 2 points, we need that distance to be 0. So we take the limit knowledge and we apply that limit knowledge by saying the distance between the 2 points is shrinking down to 0. And we rewrite this as f of, and it's written up there, but I'm reusing it, f of b plus h minus f of b all over b plus h minus b. You see how it's still falling in line with the slope formulas above? This time it's a limit though, because we are limiting the distance between the 2 points to 0. In other words, we're taking those 2 points and we're shrinking them down to 1. So we have, finally, the limit as h approaches 0 of f of b plus h minus f of b all over h, because when you do b plus h minus b, it combines like terms, you reduce down to just h. So this right here is what's called the limit definition of the slope. And there are 2 alternative ways to deal with this. So I'm going to write them out, two alternative ways to deal with this. If you know the exact point you want the limit at, and I shouldn't say limit, if you know the exact point you want the slope, you're going to use x equals a. Now, you don't have to use a. You could use any letter of the alphabet. We already used C and B up here, all right? So if you know the exact value of the point you want the slope, you're going to rewrite this as the limit as x approaches a, because what you're doing is you're saying, okay, there are 2 points, but I want them both to be at the same point. So I'm making them approach each other. F of x minus f of a all over x minus a. So there's option number 1. If you know the exact point, you want the slope. So let's say you know that you want the slope when x equals 2. You use that. We're going to get into more examples, but use that one if you know the exact point. If you don't know the exact point, so in other words, if you just want a general rule that will work at any time because you don't know the specific time you want it, otherwise, you're going to use this. The limit as h, so some generic distance approaching 0 of f of x plus h minus f of x all over h. There are your 2 limit definitions of the slope. We are going to be using them interchangeably in the next several slides. Make sure you've written these down because we're going to come back to them. And I'm going to pause it here.